Hey guys, how you doing? This is Coach Scott. Let's move on to our next video in our series on covalent bonding. We're getting ready just to learn how to draw Lewis diagrams, right? And very important little deal. Let's remember the octet rule. Remember that atoms tends to have a full valence shell configuration. So for most atoms, that means it wants to have 8 valence electrons. So when we do covalent bonding, molecular bonding, the atom will share the electrons in an effort to get those 8 electrons around it. Now there's some exceptions, and here's some exceptions. All right, sorry. Hydrogen, all it needs is 2 electrons, just 2 electrons. Let me give you a nice little pen out here. I'm going to need it. Let's go green. We'll go green. Hydrogen, it gets 2 electrons. It's got a full configuration. Now beryllium, a weird one, it only needs 4 valence electrons. Boron only needs 6 valence electrons. And those are the weird ones, right? Thank God. That's all we have to worry about right now. All right, so what a Lewis structure is a diagram that has the valence electrons, just the valence electrons, and we write them as dots. Now we also call them Lewis dot diagrams or Lewis electron dot diagrams or whatever. Now notice that there are no electrons are paired until we get the 4th one. Like this lithium's got a valence of 1. We'll just put that little dot right there. Beryllium, we don't put those together. We separate them like so. Boron, group 13, it's got 3 valence electrons. We do like so. Okay. Now, carbon, the 4 around, and I'm just figuring dots. Now, notice with nitrogen, we've got all 4 around it. That's where we'll pair them up, okay, in the orbital, if you would. Now, helium, we'll pair them up right off the bat. Why? They've only got 2 electrons. Okay, so that makes sense. And if you notice, sodium, lithium, they all have 1 dot next to them. And I encourage you guys to write your dots like this, okay? Because it keeps you from, well, getting in trouble. You'll find out why later. So, we'll talk about a single covalent bond, a single bond. So when these 2 nonmetals, they share their electrons, and that completes their outer shell. Let's look at hydrogen and fluorine, right? So hydrogen by itself has 1 valence electron. There it is right there, 1 valence electron. So if they come together, they'll chit-chat and talk, and they'll say, hey, let's share this electron. All right, I'll share mine, you share yours with you, I'll share mine with you. Okay, we've got our pair, we're happy. Fluorine has, 7 valence electrons. So if they were to share their electrons, they're sharing that electron to get that full, they feel like they've got their full 8. So this fluorine says, cool, I got my 8, but I'm going to share this one with you. And this is saying, all right, by sharing, we have our 8, we're happy. That the sharing is what we call the bond. So this Lewis dot structure, they commonly represent those bonds, the ones where they're sharing, with a dash. Okay, so here's some examples. You can put the little dots in, that's cool, or you could just put the little dash in like so. That dash means you've got a shared pair of electrons. Okay, yay. Sharing is caring. All right. Now, if a pair of electrons is not, valence electrons is not shared, we call that a lone pair, or a shared pair, or a non-bonding pair, because it's just out there. So each of those is what we call a lone pair. So they actually do some things we'll find out later. Like this is ammonia, NH3. Nitrogen has that lone pair right there, and it does influence how we'll find out later, does influence how that molecule reacts. So let's talk about how do we draw a Lewis structure. We have 7 steps when you draw a Lewis structure. Number 1, find the total number of valence electrons in the compound. Okay. Then the central atom is going to be the least electronegative element. A little to the left, if you would. Other than hydrogen. Hydrogen can only have one bond, so it's never going to be the central atom. Now then we're going to connect each of the atoms by a single bond. Each of those single bonds will count as a pair of electrons. Okay? Step 1 through 4. So what we do next is we're going to add electrons to the outer atoms to give each one 8, counting the paired electrons, with some exceptions. They were beryllium, boron, and hydrogen. Then we're going to do the same thing for the central atom. Then we're going to check, does each atom have a full valence 8 shell influence? Okay. Then have we used up all the valence electrons? Then we have to think, have we used too many electrons? So let's work a couple. So I'm having to draw PCl3, phosphorus trichloride. So first, we're going to find the total number of valence electrons in the compound. Phosphorus, look on our chart, has 1, 2, 3, 4, 5, group 15. It has 5 valence electrons. Chlorine, in group 17, has 7 valence electrons. So we draw them around 5 electrons around phosphorus. So the total number of valence electrons would be 5 from the phosphorus. And I've got 3 chlorines with 7 each, so that's 3 times 7, that's 21. 21 plus 5 is going to be 26. Now, if we look at our charts of electronegativity, we see that phosphorus is 2.1, chlorine is 3.0, so the least electronegative would be phosphorus. Then we're going to connect the other atoms to it by single bonds. All right, so we looked here. Phosphorus 2.1, chlorine 3.0, phosphorus is going to be the central atom. So I'm going to put phosphorus there in the middle. Then I'm going to put a bond around each chlorine. Now remember, that's 2 electrons. All right. The line means 2 electrons. Okay. So far, so good, I hope. So then each of those is 2 electrons. Then I'm going to add an octet around each of the outer electrons. 1, 2, 3, 4, 5, 6, 7. 1, 2, 3, 4, 5, 6, 7. All right. And of course, that's got 2, that's got 2, that's 8. 1, 2, 3, 4, 5, 6. All right. Then I've got to put 8 around the central atom. 1, 2, 3, 4, 5, 6, 7, 8. Put a lone pair. Then we have to ask, does each atom have a full outer shell of 8? Okay, cool. It does. 1, 2, 3, 4, 5, 6, 7, 8. 1, 2, 3, 4, 5, 6, 7, 8. 1, 2, 3, 4, 5, 6, 7, 8. Yeah, you get the deal. All right, so have we used our electrons? Remember, we were trying to get 26. So there's 2, 4, 6, 8, 10, 12, 14, 16, 18, 20, 22, 24, 26. We've used up all the valence electrons. So that would be the Lewis structure for phosphorus trichloride. Yay us. So let's look at ammonia, NH3. Number 1, find the total number of valence electrons in the polyatomic ion or molecule. Okay, so nitrogen has 5, and then hydrogen, of course, has 1. We've got 3 of those, so that's going to have 8 total electrons in the molecule. Good. So the central atom is going to be the least electronegative atom. element, except for hydrogen. Hydrogen can never be the because it can only have one bond. So our central element is going to be nitrogen. It is. Then we're going to connect it. Ooh, let's see if I can move this. I did. So we're going to connect nitrogen, the hydrogens to nitrogen with a single line, which would be two, or a pair of electrons. Okay, so we do that. Nitrogen central is the least electronegative, and it can't be hydrogen. So each of those would be 2. I'm going to go ahead and label those. So that would be 2. Sorry. Get my pen back. And let's switch to purple. So there's 2, 4, 6 electrons. All right. So we're going to make sure that they have a full octet, or in hydrogen case, it has 2. Each of those has 2 around it. Then we've got to make sure that the central atom has a full octet. 2, 4, 6. I got to put 2 electrons around there. Okay, so now there's what we got so far. Does each atom have a full outer shell? Well, hydrogen has 2, that has 2, that has 2. Good. Nitrogen 2, 4, 6, 8. It's got a full octet. And I've got 2, 4, 6, 8 electrons. And if I go back, that's how many I had in the molecule. Let's double check. All right, back one more. And we had 8. So we've used 8. We have drawn the Lewis structure for ammonia. Yay us. How many valence electrons does nitrogen have? This is old hat. That's going to be 5. How many electrons are shared by 2 atoms to create a single bond? 2. How's a covalent bond represented in a Lewis structure? Well, it could be a dash. It could be 2 dots. So, of course, that would be A and C. Which element in H2O is the least electronegatives? All right. If I recall, I think it's hydrogen. And let's look at the answer for that, because I'm really positive it's oxygen, and it is hydrogen. Okay, so oxygen is more, has a higher electronegativity than hydrogen. I think it's 2.5 versus 2. How many total valence electrons does H2O have? Okay, so oxygen has 6. Hydrogen has 1, and I've got 2 of those. So that's 2, so it's going to have 8 valence electrons. 6 plus 2 equals 8. So that's Lewis structures, or the introduction to Lewis structures. And you'll see as we do it, like let's go ahead and do H2O. There's oxygen. All right, I've got 2 hydrogens. We'll do that one real quick. Those are 2 electrons. That's 2 electrons. Now oxygen will have, now it has 8 around it. And if you look, those 8 total electrons. That's the Lewis structure for hydrogen, or for water. So again, guys, it's tricky sometimes, but for the most part, it's pretty straightforward. I think you'll do very well with this. So yeah, we'll talk about this more in class tomorrow. So anyway, this is Coach Scott saying have a great evening. Bye.